This video is going to look at percent composition in a compound, and this little video, little chemistry humor here, if you read through this, it's talking about, how he's going to fill them full of 98% lead and 1% antimony and trace amounts of other different chemicals. And that's what percent composition is doing. It's taking a compound and it is looking at how much of each element is in that compound. We could add up the atoms. For instance, water has 2 atoms of hydrogen and 1 atom of oxygen, but percent composition is more than that. It is looking at the mass. So percent compositions are going to be percent by mass of the element in the compound. So when we're doing a percent composition, this little equation hopefully will help you, but to put that into words, we are going to need the grams of the whole compound. So we're going to need to look up and calculate our molar masses, and then from there we need the amount of just the element divided by what the total formula mass is. Kind of like when you're getting a test back and it has a certain percent on it. It's your score over the grand total number of points and then multiplied by 100 to get your percent. That's what we're doing here, only we're looking at the mass of the element over the total mass of the whole compound and dividing that or multiplying that then by 100 to get our percent of mass. So we're going to do an example here. We have 13.60 grams of a compound, and that compound only has magnesium and oxygen in it, so that would be magnesium oxide. We could write that formula if we wanted to. And it's going to get decomposed. We haven't talked about that yet, but that just means it gets broken down into magnesium and oxygen separately. And when we do that, we get 5.40 grams of oxygen. And that must mean that the rest of that, if we were to take the 13.60 and subtract 5.40, that would be how much magnesium we have, okay, by default, since there's only the 2 elements. And we want to know what the percent composition is of this compound. So remember, when we're doing percent composition, we want the mass of just the element, and we need to know the mass of the whole amount, so the mass of our compound, and we're going to be dividing those and then multiplying our decimal by 100 so that we get a percent. Alright, so let's start off with oxygen. They gave us what we need for that one to start off with. We know that the mass of just the oxygen is 5.40 grams, and the whole entire mass of the compound was the 13.60 grams. So if we divide those and then multiply by 100 and keep with our significant digits here would just be the 3 for the 5.40, we are going to get 39.7%. That's just oxygen. Now, to calculate the magnesium, again, we know that the magnesium is whatever isn't used of that 13.60. So if you subtract that, 13.60 minus 5.40, you get 8.20 left. So that's how much magnesium we must have had, since the rest of it was oxygen. So if we now take the mass of the magnesium, divide it by the mass of the whole compound, and multiply that by 100, we end up with 60.3. And that is how you do a percent composition problem. Okay, let's do another one. Now we want to calculate the percent composition of propane. Propane is C3H8, and they gave us the formula specifically because you notice they didn't tell us what the mass of the compound is. We have to be able to figure that out by doing a molar mass. We can get the number of grams in that. So for carbon, we have 3 carbons, and if you look at your periodic table, each one's 12.0. So the mass of just carbon is 36.0 grams. And then we also need to add in our hydrogens here. We have 8 of those from our formula. Each one is 1.0. So we have 8.0 grams of hydrogen. So total for propane, for the whole compound, we're at 44.0 grams. So there's our C3H8. Now just to do the percent of carbon, we need to take the mass of just the carbon, 36.0 grams, over the total of 44.0, multiply that by 100 once we have our decimal, and you should get 81.8. Now you're only allowed 3 significant digits. When you divide the 36.0 by 44.0, each one of those has 3 significant, so 3 significant in our final problem. And then we also have the hydrogen that we need to do. That one you have 8.0 grams over the 44.0. And we divide those, multiply it by 100. And you can stop this at any time. You should definitely be trying this out in your calculator. Please don't take my word for all of this. You know I make mistakes. I've made plenty. Notice that this one's only 18, and that's because the hydrogen only had 8.0. There's only 2 significant digits there. So our final problem can only have 2 significant digits. Now if you add those up, okay, the whole goal is, you know, to get that 100%. If you add them up, you're not going to get quite 100%, but when we add, the rule for significant digits is you go by the lowest number of decimal places. The lowest number of decimal places is no decimal places. Okay, 18 doesn't have a decimal place to it, so we would only be able to keep these first 2, and the 8 we would use for rounding, and hence we get 100%. So significant digits are really important, and it should work out when we add things up and all that we can still get the 100% because of the rounding. So be careful with your significant digits. Alright, we can also use percent compositions as a conversion factor. If you think about what a percent is telling you, the percent is telling you how many grams of that element you have out of 100 grams. So once you've converted it to a percent, you're really saying, like for a hydrogen for instance, you're saying that if it's 18% hydrogen, then you have 18 grams out of 100 grams. Or for carbon, 81.8, you're saying out of 100 grams, 81.8 grams of that would be carbon. So we can use the percent as a conversion factor, and we're going to do that for our last problem here. We want to know how many grams of carbon and how many grams of hydrogen there are if we have an 82.0 gram sample of our propane. Now 82.0 grams is of the whole entire compound. So if we start with that, we want to know just what our amount of carbon is and what our amount of hydrogen would be. So if you think about the percent as a conversion, and we did the propane example 2 slides ago, we said that for carbon, if we want to start with that one, there's 81.8 grams of just carbon out of a whole entire 100 gram sample of our propane. So our grams of propane cancel, and we're left with just how many grams of carbon would be in that sample. And if you multiply your 2 numbers and then divide by 100, you get 67.1 grams of carbon. We also need to do the same thing for our hydrogen. We still have our 82 gram sample, but obviously out of that 82 grams, only 67.1 grams is carbon. And you got to be careful with significant digits, so you can't just subtract 82 minus 67.1 and say that's how much hydrogen I have. You've got to use your calculations here and look at your significant digits. We did have 18 grams, 18% hydrogen, so that's 18 grams out of a 100 gram sample of our compound. So our grams of propane again are going to cancel, and if we take the 82 times 18 and then divide that by 100, you're only allowed 2 significant digits here because of the 18 from the hydrogen there. So that's 15 grams of hydrogen. And if we were to add those up to see what, make sure that our masses, add up to the 82.0, you are going to have this adding up to 82.1, but you're only allowed no decimal places because of the 15, so that would round to 82 grams, which is what we had here in our original problem. So you want to be careful. You can't just, subtract things and say, oh, I'm going to have 15.9, whatever it is. You got to make sure that you're doing the significant digits. So that's percent composition and how we can use that to determine the mass of elements within a compound.